Question number 9.
Yeah. Like those type of questions I can really understand.
Oh, no problem. Let me find my pen. All right. The question says, simplify this raised to the power this.
Yeah.
The formula, sorry, the rule that we have is a raised to the power m bracket n. We end up writing the base as it is and essentially end up multiplying the powers in the numerator, sorry, in the exponent. So what I'm going to do is end up multiplying these two, and then there's a 1 over here that we haven't written, and I'm going to end up multiplying those two. So let's do that. X raised to the power 3 multiplied by -4 into 3. And then we have that fraction sign over here, remember? That's going to be there. Hold on. And then what we're going to do the same process in the denominator. 8 raised to the power 1 times or multiplied by -4/3. This is all happening in the exponent or the power. This 3 gets simplified with this 3. We're left with x raised to the power -4. Let me know if it stops making sense at any point in time. Okay?
Yeah.
And then we've got 8 raised to the power. What do you think the solution is going to be for this part that I've just circled over here?
Just
my little ones here. I need to
just -4/3.
-4/3. Hold on, I need a minute. So what do you think the answer is going to be? 8 raised to the power?
-4/3.
-4/3. Now we're still stuck because that's a long way off from the answer. What are we going to do? Remember this process where we divide 8 into multiple smaller parts and we call it prime factorization?
Yeah.
What can I divide 8 with? What prime number?
2.
2. So if we divide it with 2, we get 4 glass. If we divide it with 2 again, we get 2. If we divide it with 2 again, we get 1. So 8 it can essentially be broken down and written as 8 raised to the power. Sorry, 8 is equal to 2 raised to the power.
Oh, just, yeah.
Come again?
Wait, sorry.
Can 8 be broken down and written as 2 multiplied by 2 multiplied by 2?
Yeah, so 6.
It's 8 is equals to 2 cube. Can I rearrange 8 and write it as 2 raised to the power 3?
Yeah.
All right. X raised to the power -4 divided by, I'm going to end up writing 2 raised to the power 3. And then we've got -4/3 outside as it is. Rida, if it refuses to make sense, let me know there and then, because if you stay quiet, it's only going to harm you in the long run. You know why? Because I'm going to send you a worksheet and then probably you might take a test at some point in the future. Those troubles, those queries are going to carry on and they're going to trouble you in the long run. So let me know as soon as it stops making sense.
Yeah.
So does this make sense how we change 8 into 2 cubed?
Yeah.
Perfect. Now, it's going to be x raised to the power -4. How can I simplify this part?
Would you do, times 3 over -3/4/3, the powers together?
The powers are going to multiply, and what can I cancel?
The 4? No.
What's the 4 going to get
3.
canceled? We're going to cancel the 3s. The 3 is going to get carried out with this 3. You know why? Because we're essentially writing it like this: 3 multiplied by -4/3. 4 is going to make it past this is equal to sign as it is. This 3 is going to get cut down with this 3. We're left with -4 in the numerator. Sorry, in the power. Now what do we do?
Do we cancel out -4?
We would have been able to do that had it been written like this. But since it's in the power, we can't do that. And since the bases aren't same, we can't do that either. What if I were to tell you that this is the answer?
Oh,
We just need to take the reciprocal so that this goes in the numerator, this goes in the denominator. And this is going to be 2 raised to the power 4 over x raised to the power 4. What did I do over here?
you just switch the powers over so it becomes positive.
Perfect. I just switched them so that their powers become positive, and this is the answer. If you want to, you can always change 2 raised to the power 4 into one number. That's going to be, what is 2
Should just-
multiplied by 2 multiplied by 2 multiplied by 2?
8.
Almost there.
Hmm?
2 raised to the power 3 is 8. 2 raised to the power 4 is
2. 60.
16. 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. We're going to write that down over here. So this is your answer. All good?
Yeah.
Perfect. Any other question?
No.
The only question that you had trouble in was question number 9. That's it?
Yeah, it was just questions that were like that. I didn't know if you, because it was like a fraction type of statement. I didn't know if you were meant to times them together or
All right.
divide them.
All right. We quickly take a look. There are a couple of questions that aren't there in the solution. I mean, just a few. And to name one, I think it's question number 10. You skipped that as well. You want me to go
Yeah.
through it over here?
Yes, please.
Okay. 2 raised to the power 3. I mean, you cannot do anything with this. This is already in its basic most form. However, 4, you see, is a perfect square. What can you change the 4 into so that it kind of relates to this guy on the left? I mean, is there anything that you can do to 4 raised to power p? I mean, can essentially, can it be broken down into something else? Just like, remember, we broke down question number, the number 8 in the previous part to multiple 2s. Can we break down 4 into multiple other numbers?
Yeah.
Let's do that. 4 divided by 2 is going to give you
2.
Yeah, well done. Another 2 would give you 1.
Yeah.
Now watch closely. What I'm going to do is turn that 4 into 2 square. Does that make sense?
Yeah.
What happens to that p outside that we completely skipped?
Does it go outside the bracket?
Excellent. So we've essentially written down the same thing, but just in a different format. Now what's going to happen with these two guys over here?
They're going to times together.
They're going to get times together. We can write 2 raised to the power
2 raised to the power 2p.
Excellent. 2 raised to the power 2p. If you remember the lesson, we discussed the fact that if two terms are equals to each other, I mean, one is on the left-hand side of the equation, the other one is on the right-hand side of the equation, and their bases happen to be the same, what can we do with the powers?
We times.
Can multiply them. There was one
Yeah.
other thing. Any clue?
Not really. I can't remember.
No problem. What we can say is, since the bases are same, we can simply equate the powers and say 3 is equals to 2p. And in fact, for you, for it to become easier for you to remember, I'm going to write it down in a separate color. I'm going to write it down in a separate color. Here you go. What you can do is write 3 is equals to 2p. What I've essentially done is I've primarily cut down both 2's and I've dropped the 3's. 3 over here, 2p over here. Does that make sense?
Yeah.
That's another rule. You can simply cut down the bases and drop the powers in the place of the bases and equate them. How can I solve for p now? What can I do to find the value of p?
Would you not too sure? I don't know.
No problem. No problem. Let's solve this. 2x plus 5 is equals to 10. How would you isolate the variable x?
G divides 10 by.
But that's the last step.
Okay.
The rule that I've come up with to help students understand this concept is that you're supposed to go the opposite direction of board mass. So if I go the opposite direction of board mass, which letter am I supposed to deal with first?
2x plus.
What does this S stand for?
Subtraction.
Subtraction. So whatever's getting added into the expression needs to go over there and get subtracted, because addition cancels subtraction. This is how that works. Board mass works in pairs. Addition cancels subtraction and multiplication cancels division. So whatever is getting added needs to go over there and get subtracted. 5, you basically, essentially, what you're trying to do is you're trying to isolate the variable x, right? That's what's called subject making. Are you familiar with this?
Yeah.
What I'm going to do is I'm going to get rid of this 5. How? I'm going to throw it on the other side, and I'll say I'm done with subtraction. Why? Because that's what I've essentially done. I've canceled addition with the help of subtraction. Wait, hold on. Let me add another step so it might make more sense. Technically what you're doing is you're subtracting 5 from both sides. I'll do that in another color. I'll color code it for you. If I need to get rid of this 5 on the left hand side, I'll subtract 5 from here, take away 5. I'll take away 5 from here as well. Now, if you notice this plus 5 and minus 5, they completely cancel each other out, right? We're left with 2x is equals to, what is 10 take away 5?
5.
5. Excellent. We're done with this part. We've just done subtraction. And there's nothing left for addition as well. So we're done with addition as well. I mean, there's no plus sign or minus signs left. Now we're coming back to the part where it's M and D. What does M stand for?
Multiplication.
Multiplication. What cancels multiplication?
Division.
Division. Now multiplication will get cancelled with division. It works in pairs. Since 2 is getting multiplied with x, what can I do? Can I divide both sides with 2?
Yeah.
If I do that, would I be essentially able to cut out this 2 with this 2?
Yeah.
I'll be left with x is equals to 5 divided by 2, or 5 by 2. Does that make sense?
Yeah.
Let's take this example back here on the left hand side and try to solve this. 3 is equals to 2p. We're on the last step. We need to isolate p. How do I know that? Because the question says so. Find the value of p. Right?
Yeah.
The question says find the value of p. What's getting multiplied with p?
2.
2. And what cancels multiplication?
Division.
Division. So we're working along this pair, right? Does that make sense so
Yeah.
far?
Yeah.
If I divide both sides with 2, would I essentially end up cutting this 2 with this 2?
Yeah.
So we've successfully eliminated the variable, the number 2. We're left with p on the right hand side. We're left with 3 by 2 on the left hand side. Can we say this is our answer?
Yeah.
So this was easy, right?
Yeah.
Perfect. Any other question that you've left out?
I think so.
I think this question
Yeah.
number 7 as well. Here we go. Do you remember something that looks like this?
Yeah.
What can we change in this form into? This is what do you call it? A radical sign. The square root sign, another name for square root sign is a radical sign. How can I change this radical sign into a fractional index form? Fractional index form basically kind of looks like this. One value over another.
Yeah.
How can I do that? What will this change into?
A m over n or.
Excellent. Whatever is in the numerator, whatever is inside the radical sign goes in the numerator. Whatever is outside the radical sign goes in the denominator. Remember that?
Yeah.
if I change this into a fractional index form, what can I write it as? Y raised to the power
2/3.
2 over 3. Excellent. What can I write this as?
X 1/6.
1 over 6. Now the question says, and y is also equals to this. Let's write that down as well. Y is equals to, what can I rearrange this part of the expression and make it look like in the form of an fractional index?
1/n.
1 over n. Excellent, excellent, excellent. Now let's see if this helps. They're asking us to find the value of n. What we've successfully done is change the radical sign into a fractional index form.
Yeah.
Does this help? Can we solve it further now? I mean, try to go back, revisit all those rules in your head, and see if we can somehow introduce one of the variables in the other equation and substitute it and try to solve it. What if I were to say, since y is equals to this, what if we were simply to pick this up and substitute it over here? Would that help?
Yeah, I think so.
Look, if I were to say a is equals to b, right?
Mm-hmm.
Then if I say b is equals to c, can I say a is equals to c?
Yeah.
That makes sense, right?
Yeah.
If I were to tell you, now watch closely, y is equals to x raised to the power 1 over n. Can I say this y was equals to this y?
Oh, yeah.
Right. Can I also say this x raised to the power 1 by n is also going to be equals to this?
Yeah.
That's exactly what we're going to do. What we will try to do is bring this over here and write, instead of y, just simply write x raised to the power 1 by n. What is going to happen with this power up here? Where is this going to go?
Would it go to the other side?
Remember, we just changed the y and wrote x raised to the power 1 by n. This is still going to be out here. This is going to stay right next to the variable y. And since we changed y and wrote it as x raised to the power 1 by n, the 2 by 3 is going to drop as it is. We essentially only changed this value. Rather, we only changed y. Instead of y, we wrote x raised to the power 1 by n. Does that make sense?
Yeah.
The raised to the power 2 by 3 is going to be there as it is. We did not change it. That's going to drop as it is. Right? Makes sense? We're going to write this. We're going to drop this as it is and write x raised to the power 1 by 6. I'm pretty sure you can lead from here. What's going to happen with these two powers now?
Will they multiply together?
Perfect. X raised to the power. Now, what is 2 multiplied by 1?
Just 2.
And what are these two numbers multiplied together, these two terms?
2/3n.
Not quite. I can rearrange it. I can let me write it down again for you over here. 1 over n times 2 over 3. If I were to multiply these, the numerator gets multiplied with the numerator, that becomes 2. The denominator gets multiplied with the denominator, that becomes 3n. Simple. Does that make sense? So you've already helped me write down the 2. What am I going to write in the denominator?
3n.
3n, that's it. And once on the other side, we've got x raised to the power 1 by 6. Remember, we discussed a rule in the previous question that whenever the bases are same, what can we do with the powers?
We cancel them out.
Come again?
We cancel out the base.
We cancel out the bases. We can just cross them out. We can say they do not exist anymore. And we can drop the powers in their place and write 2 divided by 3n is equals to
2 is, wait, just 2, 1 over 6.
1 over 6. We're not trying to simplify 2 by 3n over here. Remember, we had an equation in the first step, in the step before the step. We are just trying to put that equation down in the next step as well. And we're in the process, we're trying to eliminate a few terms from it. So we just eliminated x from the basis. We're just going to drop the powers as it is so that we can form a new equation. We're not going to simplify 2 by 3n right now. Now, whenever we have a fraction is equal to another fraction, what do we do to solve for n or isolate the variable n?
We multiply it.
What's that particular multiplication called? There's another term, not just multiplication, it's what sort of multiplication?
Yes.
We cross multiply.
Oh, okay.
Does that make sense? Let me
Yeah.
remind you what that is. Let's say it's a over 5 is equals to 2 over 10. What do I do whenever I have, watch closely, and I would want you to take down notes. This is going to come in
Yeah.
often in algebra. Whenever we have a fraction equal to another fraction, whenever we have something that looks in the form of, you've got a fraction equals to another fraction, you always cross multiply. What you're going to do is you're going to end up multiplying this a with 10 and this 5 with 2. That's going to be 10a. 10 times a is 10a, right?
Yeah.
What is 2 times 5?
10.
10. Rida, I would want to know some few terms. For subtraction, minus, you don't call it subtraction or minus, you call it take away, right? That's what you're familiar with. What term do you use for multiplication? I would want to use the same term so that you don't have to constantly translate what I'm trying to say.
Oh, we just call it multiplication, subtraction. It's just.
Are you sure?
Yeah. It's just
Because I would want to use the same terms that you use so that you don't have to constantly worry about what I'm saying. Are you familiar with multiplication and the fact that I'm calling takeaway subtraction?
Yeah.
Okay. All right, perfect. We've got 10a is equals to 10a. How do I isolate the variable a? How do I solve for a?
Would you cancel? No. Divide the 10.
Perfect. Division cancels multiplication, and since 10 and a is written right next to each other, they're getting multiplied. So what would cancel 10? I'm going to divide it with 10.
Yeah.
Right? Since a is getting multiplied with 10, how do I get rid of 10? Because it's getting multiplied, I will divide it with 10 so that it cancels out. Now, whatever I do on the left-hand side, I also have to do it on the right-hand side. I'll even explain why I have to do that. So we essentially primarily end up dividing 10 with 10. We're left with just a. I'm going to write that down over here. A is equals to, what is 10 divided by 10?
1.
1. We solved for a and the value comes out to be 1.
Yeah.
Let's quickly do this, and I'm going to then take you back to the concept of why whatever we do on one side of the equation, we have to do the same thing on the other side of the equation. All right. I'll take you back there, but after a little while. Let's discuss this first. We've got this equation. What do I do now? We have a fraction is equals to another fraction. What do I do?
You do 2 times 6 and 1 times 3n.
Excellent. 2 times 6 is equals to 1 times 3n. And 2 times 6 is?
12.
12 is equals to 3n. How do I isolate n? How do I get rid of this 3?
You divide them by, yeah.
On both sides, right?
Yeah.
We just left with n. Now, what is n equals to?
N equals to 4. Wait, do we divide 12? Yeah, 4.
Perfect. Let me show you why we choose to, whatever we're doing on one side of the equation, why do we choose to do it on the other side of the equation? Are you familiar with this? I'm just going to make a drawing, nothing technical. Do you know what
Yeah.
this? Do you know what this is? Is this familiar?
Oh, yeah.
What is this?
It's a weighing
It's a
thing.
weighing scale.
Weighing
But
scale.
let's say there are two boxes here. And let's just say there's just one big box here. Imagine if this is 15 kgs. Are you familiar with kilograms?
Yeah.
And this one is X kilograms. And this one is 7 kilograms. What must that X kilograms weigh for it to balance out?
The at 7, 8 more 8
8. Perfect.
kilograms.
Now, how did you do that? Essentially, what you've done, take a good look. I can call this the left-hand side. I can call this right-hand side. Does that make sense?
Yeah.
I'll say X plus 7. This will come down in the middle part where the weighing scale is getting balanced on. The pillar is going to come down as an is equals to sign, and the right-hand side would drop in as 15. Now, how do I get rid of this 7? We've just discussed that a little while ago. If it's getting added over here, what do?
You subtract it.
We subtract it. Rida, pay close attention. We subtracted from here. We also subtracted from here. I'll show you why. Take a look at the screen. If I remove this box, take a good look. It's gone, right?
Yeah.
Can I say the 7 kilograms is gone? Can I erase this?
Yep.
There it goes. Since I've erased that or removed that box from there, would I not also have to remove a certain part of this box so that this balances out?
Yeah.
Would I not also have to remove this part of the box? So I'll have to equally remove some weight from here as well so that it balances out. Otherwise, right-hand side is going to drop. It's going to be heavier, right?
Yeah.
Okay. Now, if I take away 7 from a 7, do they essentially get cut out?
Yeah.
I'm left with X is equals to, what is this number equals to? This expression? That's exactly the number that you told me, remember? X is equals to 8.
Oh, yeah.
Remember, before I removed that box from here, you told me that box was gonna, the box that we had down here that I removed, you told me that the box is gonna weigh 8 kilograms. Now you did that mentally, right? You solved it in your head.
Yeah.
We just did that through algebra. Does it make sense?
Yeah.
We've just done that through algebra, and what I've essentially told you is why you end up doing this. Whatever you do on one side of the equation, you also do that on the other side of the equation for it to balance out.
Yeah.
Because we ended up removing 7 from one side, we also removed 7 from another side. And then the weighing scale is going to balance. And once it balances, what do we end up finding? We end up finding the value of X. What does that value of X represent? Sorry, that value 8 represent? The value or the weight of the unknown box.
Yeah.
That's 8, remember?
Yeah.
All right, we are done with this as well. This you've already solved. You've left another question. Question number 5. 4 you're done with. You left 3 as well. You left 2 as well. Rather do me a favor. Although I'll check the worksheet that you've sent me, but you've just learned 2 more concepts, right? Although we have discussed them before, I mean, you just got a revision of those as well. a practical revision of them. We were trying to solve them, or we were trying to apply those rules with the help of some questions. What if I ask you to do these remaining questions, just 2 or 3 that are left, again,
Yeah.
and then resend that worksheet? Would that be possible?
Yeah.
So that I can in one go check out the entire worksheet that you've done, instead of just sending it back to you again or going over through them again, that you left out question number 2, 3, and 4. So let me just mark them for you. You need to do question number 2. Write that down, please.
Yeah.
Question number 3 and 5. Just 3 more to go.
Yeah.
However, take a quick look. Do you have that worksheet in front of you? Even if you don't, you just take a look over here. If you even slight bit feel that you would not be able to do these, I can do them over right in front of you. Take a look over here. Would you be able to do this now? Or does it seem difficult?
I think
Not sure?
not too sure. No.
Not too sure. If you're not sure, I'm going to do it right now. What about this one? Would you be able to do this?
I think so. Yeah.
All right.
Yeah.
What about this question?
Yeah, I think I'll be able to do that.
Perfect. We will just do question number 2, and then you just need to do question number 3 and 5 and send that worksheet again.
Yeah.
Let's try to do this. We need to find the value of y, or in other words, we need to isolate the variable y. If we use the rule of board mass, and whenever we're isolating, remember what do? We use the opposite of board mass. You're not going to find that rule anywhere in the book. I've just come up with that rule. I've just tried to put that. I've taken up an essentially existing concept and tried to come up with the rule so that students find it easier to find the rule, to find the unknown variable, right? If you tell anyone that in order to find an unknown variable, you need to use the opposite of board math, I don't think they'll be able to relate to you. So before you end up telling that to anybody, I think you'll have to break it down why we do that. Because whenever we're trying to find some variable which is stuck inside a complex expression, if we use the opposite of board mass, we're easily able to isolate y. So if you take a look over here, this one is getting subtracted. Subtraction is all the way down here, right? What cancels subtraction?
Addition.
Addition. I'll write 3, 2 raised to the power minus y over 16. Now take a close look. Since you said addition, I'm going to add 1 on both sides. Take a look. All right, I'm going to solve the rest of the question once we join back. The meeting's going to end, all right? आप इसको try करो. Do the remaining part of it, and we're going to join another less than a minute, I guess. Okay?